Now let's look at what the nth term would be from the end of an AP. Now this is a concept that would be again be same for GP and HP as well when we study those. Sometimes what happens in questions is, for example, till now we have seen that the question that are asked are somewhat like this: find the 7th term of an AP, find the 12th term of an AP. For example, what if JEE asks find the 7th term from the end of an AP? Then you will need to use this formula to find out what would that term be from the start. For example, let's take again the same sequence, for example 20, 25, 30. So how many terms are here? 1, 2, 3, 4, 5, 6, 7. So we know n is equal to 7. Now let's say in the question they ask what is the second term of this AP. So we know it is 5, right? If they were to ask what is the second term from the end of this AP, then right now, since we can write the sequence, we know it is 25. However, if the sequence would have been infinite or a very large sequence, then we would have been needed to calculate it using this formula. So since we said that the second term from the end, this is the second term from end, what would this term be from the start? First, second, third, fourth, fifth, sixth. So this is the 6th term from the start. Let's try and use this formula if we get 6 as the answer. N is 7 minus second term from the end plus 1, 6. So yes, this formula definitely works, and we need to find out the nth term from the start using this formula. Now there are a few important properties of an AP that you need to remember. First, let's see it here. Let's say again 0, 5, 10, 15, 20 continued has been provided, and if you add a constant term k to this AP, the AP would change to k, 5 plus k, k, 10 plus k, and so on. Now you see this is an AP. After adding a constant term, it still remains an AP. Here the common difference was 5. Here again the common difference remains same, which is 5. So this is an important property to remember. Let's say if we were to multiply k to this sequence, that is k. If we were to multiply a constant term k to this sequence, we would get 0, 5k, 10k, and so on. Now the common difference has been changed. D has been changed to 5k. Initially it was 5, now it has become 5k. So that is exactly what has been mentioned here. If ABC are in AP, then A plus minus k, B plus minus k, C plus minus k are also in AP, and the common difference remains same. If ABC are in AP, then K, KB, KC are also in AP. Again, we proved it. D dash, however, this becomes K times of D. This is the thing that you need to remember about the common difference. And if we were to sum, let's say taking equally distant terms from the AP and then sum them, then that sum would be same for all the terms. For example, in this sequence, let's say 20 was the last term of this AP. Sorry for that. Let's say 20 was the last term of this AP. Then 0 plus 20, first term from the start and first term from the end, would be equal to the sum of second term from the start and the second term from the end. And this would be equal to twice of the middle term. 20, 20, 20. And if let's say the middle term wasn't given, then there would have been 2 terms. Then again you would have added those and you would have gotten the same answer. And yes, since we've seen the formula of Tn to be a plus n minus 1d, we can represent this as a linear function while representing it on a graphical scale, where we consider a to be a constant, d to be an unknown variable, and n minus 1 to be another constant. So now let's look at what common differences between two APs can be. Let's say an AP is given 0, 5, 10, 15, 20, so on, and another AP is given 0, 3, 6, 9. If we were to find out what the common terms are from this AP, and we need to find out the common difference of that AP. So first let's find out what the common terms are. 0, then 15, then 30, and so on. So this is the common series which we found out from these two APs. Here the common difference was 5, here the common difference is 3, and if you look at it carefully, if we were to find out the LCM of 5 and 3, we would have gotten the same common difference as we got through the equation, which is 15, and here we see the common difference is 15. So yes, sometimes JEE asks questions about this thing where two APs have been given and you need to find out the common difference of the common terms taken up from the AP. So that would be LCM of D1 and D2. Now another concept, this is again a trick for you to solve questions. Whenever sum has been provided to you of a fixed amount of terms of an AP, then how can you assume what the terms are of that AP? For example, let's say the sum of 3 terms of an AP is 15. Sum of 3 terms of an AP is 15. Find out what is the first term. So if we assume A minus D to be the first term, A to be the second term, and A plus D to be the second term, our calculations would become much easier. Since A minus D plus A plus D is equal to 15 as mentioned in the question, D and D would get cancelled out and we would be left with just one variable, which is easy for us to solve. 3A is equals to 15 and A is equal to 5. A is equals to 5. So that has been mentioned in this table. If we were to assume 3 terms, we would assume it like this. If we were to assume 4 terms, we would assume it like this with a common difference of 2D. And if we were given 5 terms, then we would have assumed it in this manner. Now let's solve this question to get an idea of how we can use that term assumptions. 5 numbers are in AP whose sum is 25 and product is 2520. If one of these numbers is minus half, then the greatest number amongst them. That means we can assume any of these numbers to be minus 1 by 2, and then we need to find the greatest number. So first let's assume what the terms are. A minus 2D, A minus D, A plus D, A plus 2D. Since we need to find the greatest number, of course we know this would be the greatest number among all these terms. That is why we would assume this, the first term, to be minus half. So we've got one equation which is A minus 2D, which is equal to minus 1 by 2. For example, had we assumed A minus D, A or A plus D to be minus half, then we wouldn't have gotten A plus D 2D to be of its maximum value. We need it to be maximum. That is why we're assuming the first term to be minus half. So we've got one equation. Let's find out the other equation. 5 numbers are in AP whose sum is 25. Again, so we can sum these numbers plus A plus D plus A plus 2D. This is equal to 25. Minus 2D gets cancelled with plus 2D, D gets cancelled. So we get 5A is equals to 25 and A is equals to 5. We've got the middle term, which is 5. So we know if we use this value of A in this equation, then we would get 5 minus 2D is equal to minus half. Minus 2D would be equal to minus half minus 5. 2D would be equal to 5 plus half, and D would be equal to 5 by 2 plus 1 by 4. Let us solve this more. We would get 4 as the LCM, 11 by 4 as the common difference. Now we were to find out the greatest number amongst them, of course. Let's do it here. We know the first term is minus half, second term is a plus d, a is 5, a plus d, sorry, here it was a minus d, and a plus 2d. We need to find out this value, and d we found out to be 11 by 4. So we'll start adding, we'll put the values of d and a in this term and we'll get the answer. So 5 plus twice of 11 by 4, 2 2s are, and here we would get 21 by 2. So we can write this as 10.5. So this is our answer, the greatest term of this AP. Now let's say if in the question, this is an important note that you need to remember. If in the question they ask what would be the nth odd number in this sequence, for example 0, 5, 10, 15, 20, 5, 15, 25, these are the odd numbers. So if we were to find out what would be the nth odd number, then we can simply find it by using this formula. Nth odd number would be 2n minus 1, 1th term from start. And if we were to find out the nth even number, that would be 2nth term from start.